Hello everyone, my name is Gabriel Brown with Heavy Reading, where I'm lead analyst for mobile networks and 5G. And I'm here today talking with Jens Voigt. He's a 5G technology manager within the Amdocs Open Networks team. Jens, we're going to talk about RAN, we're going to talk about 5G. It's great to have you with us. Perhaps to start, could you just tell us a little bit about yourself and your background in the industry?
Yes, sure. Hi, Gabriel. Thank you for the introduction, and thank you also for the invitation here to do this podcast today. I'm happy to give a bit of my professional background. Basically, I'm with the company for almost 18 years in the meantime, and my background is all the generations starting with 2G, 3G, 4G, and now 5G of RAN, measurement, analytics, and all various kinds of optimization.
Yeah, great. So 18 years is obviously a decent shift in the industry. I guess as we're coming to the launch of 5G around the world, I've got one of the first 5G handsets here, actually launched in the UK a few weeks ago. I'm using the EE device. It's pretty interesting.
Lucky guy.
yeah, it's good. I mean, I tested the first GPRS, the first UMTS, the first HSPA, the first LTE here in London, and now 5G. It's pretty interesting. I guess from your point of view, how would you kind of characterize the current period? Does the introduction of 5G feel kind of significantly different to prior generations, or is it very similar to 4G? Would you say?
Okay, that's an interesting question, and honestly, I have two parts of an answer here. The first part of an answer would be basically we follow the same policy. So 5G was first dealt with in a research community, then it came to the standardization. The standards are now finished inside the 3GPP. And now all the natural things like the auction for the spectrums going on all around the world, and we have the trial networks, and the first commercial products are there. So we expect deployment, we expect the planning, we expect acceptance, and we will expect some optimization later on. So from this point of view, it's pretty much the same. But the second part of the answer, I think, is a more realistic one. 5G is completely different in my point of view, because this time we do not only change the air interface, which we did when we changed from 2G to 3G, we changed from the CDMA to CDMA network, then we went on to LTE with the OFDM. And now it's not just a change from LTE OFDM towards the new radio air interface in 5G. 5G is pretty much more. It is not just a new air interface, it is from our point of view a whole new ecosystem.
Yeah, that's interesting. I think even if you look at the radio, you have things like millimeter wave for mobile, hasn't really been done before. Even if you're in, it seems amazing to me that 3.5 is considered a prime band now. If you think back a few years, that was always a difficult frequency to work in.
Yeah, indeed. So the frequency ranges are pretty interesting. There's two types of frequency ranges. Frequency range 1 and 2 as defined by the 3GPP for 5G. And the first one is more or less anything below 6 gigahertz, which kind of is similar to all the frequency which we had before. And then above 6 gigahertz, there's a complete new set of properties regarding the radio channel, the propagation, the interference, all the things we have to deal with in the network planning and optimization. But on top of these frequencies, there's a new other new technology, and this is this MIMO or massive MIMO technology. So there's a new technology in terms of antennas. So there's not only single or two column antennas as we have now per sector. Instead, there's active antennas which we can steer, which we can really use for beam forming. We can have a high number of traffic beams per sector, and this will bring the real change in the network planning and optimization. And interesting is that this is massive MIMO is considered to be a 5G technology, but the first parts of this massive MIMO technology can also be added on top of LTE, of the LTE radio interface.
Yeah, it's interesting, isn't it? How, I mean, I think where people have been using LTE and TDD in some of the Asian, China and Japan and a few places, they have a bit of experience already with massive MIMO. Does just in terms of the, I guess the planning and optimization tools, is massive MIMO requiring a big overhaul there?
Oh yeah, indeed. So massive MIMO will bring a new kind of planning and optimization technology inside the tool. So we have a full new dimension of parameters. So far we had an azimuth, we had a tilt, and we had a bore height for a single antenna per sector. When we talk about 5G, then we talk about all these values per traffic beam, and we might have up to 64 or even 258 traffic beams in later deployments. And here the degrees of freedom for network optimization and for network planning are much, much higher. And this requires the first step that we see, the first requirement that we also see is to go away from the two-dimensional planning base towards a three-dimensional planning base. So we need to have high accuracy building models in planning and optimization in order to be able to cope with these high gain traffic beams when they are steered intentionally or accidentally, for instance, towards a high-rise building. So then we will have major reflections which could go into the directions of other traffic beams. And this needs to be solved probably by automatic optimization algorithms, because due to the high number of parameters here, nobody can do this manually.
Yeah, it's a massive increase, right, in the configurable parameters in 5G. One of the big, I guess, one of the biggest buzzwords in RAN right now is the idea of machine learning for RAN, particularly for optimization. What does that mean to you? Is this something we should think of as kind of an extension of CSON, centralized SON, or something else?
No, this is indeed something else. This is the next generation of network data analytics. And maybe let me explore this maybe a bit more on the detail of RAN data analytics. When we look into current 4G LTE networks, then we have lots of RAN measurement data which come in real time as streaming data. And here we talk about performance measurement counters, so KPIs. We talk about layer 3 call event traces which come in per sector. In 4G, we talk about data rates of these measurement data in terms of, let's say, gigabytes, which come in every 15 minutes. These data have an identifier with a cell ID. And what we do with these data is to do some aggregation, let's say some linear analytics. Now, when we talk about 5G, then this situation will completely change. In 5G, the set of RAN measurement data will be extended by new data sources, which the companies like we are for the first time able to access. And these are data sources which come from the lower protocol stacks, from layer 1, layer 2, layer 3. We will have them not available with the cell identifier, but with a traffic beam identifier. And as I said, alone, due to this change from a cell to a beam identifier, we have the dimensions go up by factor 64 up to factor 256. And these data will come in as a real-time terabyte data per millisecond. So we have them with a beam ID, with beam weights, and then the pure amount of these data and the pure information which is included in this data will make it a natural choice for network analytics to work with machine learning algorithms here. So we need all these types of supervised or unsupervised learning algorithms to do some clustering algorithms, to do some regressions, to find some trends, to work with labels, to work with densities.
Yeah, okay, good. So I just looked up while you're talking. Actually, one of the big RAN vendors was telling me, in a 5G radio, you have 1,000 configurable parameters versus around 300 for LTE. So obviously, you can see how that scales out.
Yep. Yeah, that's a perfect mirror. Yeah.
Yeah, in a big way. So, just talk a little bit as well about how close to kind of real time you get with, and how, you know, the parameters you're talking about, you need kind of real time optimization or as close as possible to it. Traditionally, that's been therefore the domain of the RAN base station vendor. You know, it's part of the scheduler really. As a kind of independent supplier in this space, how kind of close to the radio can you get to run these ML algorithms? Yeah.
That's I like this question pretty much. Let me go back here. When we talk about RAN, then one of the new terms coming into 5G is the term of Open RAN. And Open RAN means that most of the RAN functionalities will run in a virtual environment and will be put into software algorithms on white box hardware. So the idea is here to have an Open RAN architecture, and this one, from the current point of view in the cellular community, consists of more or less 3 layers. On top, we have the network management layer. It also does the orchestration of the network functions. The middle layer, which is a completely new layer, which was not there before, and this is a software programmable layer, which consists of 3 parts. One part is a radio information database, which collects all the measurements I've already talked about, which contains the next generation of machine learning RAN analytics, and also some near real-time control algorithms of the RAN. And then below, there's the third layer, which basically is the layer of the radio resource management and the radio resource control algorithms as we have them before. So now I introduced a new term, near real-time control of the radio access network. And this is a term which comes from a new community which is called ORAN, Open RAN, which was founded in 2018. So this initiative is a couple of more months than a year old. And ORAN basically has the target to find or to define an open architecture and open interfaces, and also to specify algorithms which can be used to optimize a radio cellular network in a virtual environment. And here ORAN specifically defines 3 different control loops. One control loop is the control loop basically of the 3GPP world. So this is anything having under control below 1 millisecond. So this is the scheduler type of things. This is the TTI or the short TTI for the URLLC communication. This is being standardized in 3GPP. But then there's 2 new control loops. One is this near real-time control loop, which shall do any network optimization, any network control, which needs a reaction cycle between 10 and 500 milliseconds. And on top, we have the so-called non-real-time control loop, which does all the network optimization above or with a lower cycle than 500 milliseconds.
Mm-hmm. Would you call that is that what we the non-real time above 500 milliseconds? Is that what we would think of today as a CSON?
Yes, exactly. So this is this non-real-time optimization inside the 5G world or inside a virtual environment is considered to be the next generation of the current CSON.
Yeah,
which can be independent of all the vendors of the lower layers, or it can come from the same vendor. We'll pretty much expect here the same type of business as in the 4G space.
Yeah, I mean, it's been clearly in 4G having independent CSON. There's many advantages to it. This middle layer, then, this near real time with the 10 to 500 millisecond control loop, is that something that an independent supplier can provide, or is that locked into the RAN vendor?
That's a good question. This is exactly a high and hot discussion inside the ORAN community currently. There was a face-to-face meeting 2 or 3 weeks ago in Tokyo, and there were indeed hot discussions about this near real-time type of RAN controller. So in ORAN, it's called a RIC, the RAN Intelligent Controller. Mm-hmm. And what became clear is that the goal of this operator-driven initiative, so ORAN is driven by operators, it's not driven by the vendors. And the goal of this operator-driven initiative towards the near real-time RIC is clearly to have here in architecture and open standardized interfaces, which would intentionally allow to come third parties as suppliers into this field.
Yeah.
So this RAN intelligent control is seen first as an end-to-end optimization. So it should not only be bound to various parts or to single parts of the network. It is secondly seen as an open architecture. So we will have open APIs running on white box hardware, just all the algorithms run in software. It should be innovative, so having machine learning in the background. It will be proactive, so we will not just wait until something in the network becomes wrong and then react. Instead, we will use machine learning and do something proactively. So we will know, we expect there might become a problem, and let's solve it before it appears.
Yeah.
And also there's this idea of this RAN app store, which I think explains everything in 3 words. So open interfaces and intentionally new, small, agile companies to come into this.
Yeah, really interesting. So just to close out then, I guess, we've talked a bit there about, I guess, if you like, logical architecture and importance of interfaces and so forth. In terms of just thinking about disaggregated RAN, obviously that's the other fashionable term. There's quite a lot of initiatives around this area. In terms of thinking about a kind of a deployment architecture, what do you see kind of happening at the moment? And I guess really I'm getting at this kind of site, whether you deploy, AU, RU, DU, CU together or separately, that kind of disaggregation. Are you seeing? I think, for example, most of the what we're seeing in Europe right now is probably more like a classic distributed RAN, I would say. Are you seeing operators actually going for a kind of novel deployment architecture anywhere?
What we see currently is in terms of commercial networks, there's a couple of trial networks which have a complete virtual implementation, especially in a small cell area. So this includes the 4G LTE radio protocol stack, so 4G RAN basically, which completely is disaggregated into a CU, into a DU, all this runs on this white box hardware in a perfect virtual space. We currently do not see this in large macro cell deployments for 4G. For 5G, the expectation here is clear. Once we start with 5G deployments, major deployments in this newly given or auctioned spectrums in Europe, then the expectation is clearly that we will only see virtual and disaggregated deployments. So there's the expectation that we will not have specific hardware solution for 5G RAN entities. Maybe the only exception might be this single RAN approach where everything, but this is also everything put into software, and there's only a software update, and then you have your 5G also on the same box.
Yeah. I share your comments there on trials. I think it will come in. My personal views, I think it's going to come in piece by piece. So, like you mentioned, the kind of small cell area or enterprise or, some particular use case or region.
Yeah, I fully agree. I fully agree with this view.
Yeah. Okay, with that, Jens, it's been great to talk to you. When we set this up, I was thinking I was talking to Jens Voigt, the cyclist, the famous German cyclist, very popular here in UK. It's turned out to be a fantastic conversation. Thanks very much.
Thank you very much, Gabriel. It was my pleasure to talk to you today. Thanks a lot. Have a nice day.
Cheers. Goodbye.